Come on, you. You all know Dennis, don't you? Yeah. He's not good with computers, you know that? He always breaks things. Yesterday he comes into the office saying, "Oh Stephen, the speakers aren't working." And I looked at the speakers, and they're USB speakers, and I was looking at the USB connection, and it was completely broken. And I said, "It looks like somebody put the cable in upside down and jammed it in." And he's like, yeah. Don't tell anybody, but I think I broke it. Because I pushed it in too hard. And I said, "Yeah, I think you pushed it in upside down as well." It's at the door. Wouldn't that be funny if it was Dennis now? I think... Oh, you want the extra class?
Yes.
Yeah. I can't do 12 o'clock because I have these wonderful students. But I sent you a text message. Did you get it? You have Isabel at 1 o'clock, yeah?
Okay.
No, wait, come back, don't be shy. You have Isabel, I think, at 1 o'clock. And then I think I will have... Oh, did I text it to you?
Yeah.
Oh, sorry. And then I think I will see you at 2 o'clock downstairs after Isabel. Yeah? Okay. Sorry, Bruce. See ya. Gone again. Something's wrong, isn't it?
No, the setting of the TV.
You think it's a setting on the TV?
Yeah, it's put on standby.
It knows I'm not doing physics. Okay, it'll do. And maybe if the image doesn't change, it thinks there's nothing on TV and goes in standby. Because I know some TVs do that. If you fall asleep on the TV, no, this is gonna be. You know, I think it is this, because as soon as I moved, it turned back on. Anyway, does anyone speak Russian? I'm not pronounced. It's Kirchhoff, but it's a Russian name, so I think you're pronouncing more like Kirchhoff. Yeah, no, not even that. Kirchhoff or something. Anyways, Kirchhoff for me. So Kirchhoffs Laws. Actually, it should be Kirchhoffs Laws. He has two of them. Very, very, very helpful laws. These are very useful laws for circuits. I don't know if anybody has studied them before. No? You've seen Kirchhoff before? How do you say his name? No, you're just copying me. Is that how you would have said it? Okay, fine. I think it's pronounced a bit differently to this. So, very useful laws. Let's see what they are. He has two laws. So he's not as important as Newton, because Newton had three laws, which makes Newton 50% more important than Kirchhoff. Okay, so Kirchhoff's first law. Kirchhoff said, for a circuit, it's called the Junction Law. At any junction in a circuit, now wait, before you start writing the whole thing down, you don't have to write the law down in words in the exam. You can write the formula down. So, what Kirchhoff said was, at any junction, the total current is 0. In other words, as a formula, he said this. Now, let me just explain what that is. If you have a junction, everything's going to be explained, don't you worry. So this is a junction where the cables connect. Yeah, and we'll say, for example, this is I1, this is I2, and this is I3. Now these currents, this one goes in, and this one comes out. If you call in positive and out negative, then Kirchhoff said I1 and the I2 and the I3 will be 0. Now if you think about it, you say, oh yeah, well of course, because we know I1 equals I2 plus I3. Because the total is constant. So as a formula, you can write it like this, that at a junction, if you add up all the currents, you'll get 0. As long as you make in plus and out minus, then the total will be 0. Oh, no, in the exam, no. Because the current already has a plus or minus, you're supposed to have a plus or minus for the direction.
Capital I and small I.
The small I just means like I1, I2, I3, yeah. It's called an index. You know index? Like for counting 1, 2, 3, I1, I2, I3. This is Kirchhoff's Junction Law. So in the exam, you can write the formula down and just simply say I means current, I1 means the first current, I2 means the second current. And this, what does this symbol mean? You know this from maths? Sum, yeah. Okay, continue. I know you're writing all the words down. I told you the formula's enough.
You just write that and then
in the exam,
yeah.
you could say Kirchhoff's first law, the junction law, is, and then the formula. And then nobody's listening to me. Yeah, I said that's enough.
No, we don't have to write like.
No, for the exam, they're happy to accept this as the definition, as long as you say what the I is. Oh my goodness. Yeah.
The small I is I1, I2, I3.
It's an index. Yeah.
And the big I
is the current. Yeah.
I thought there's only one I.
No.
That big I.
What?
Where's the big I?
Guys, come on, you know this from math class. You know you have a sequence, like x1, x2, x3. So this is like I1, I2, I3. Do you know this? Who's your maths teacher?
Yvette.
I'll have to talk to her, so. I say you'll have to repeat that lesson on sequences. Yeah? Okay, you got that? Yeah? Yes? Okay, so now on to Kirchhoff's second law. But before we just continue, sometimes in the exam they ask you what is the reason for this law. And the reason for this law is because of the charge. The charge is conserved, meaning the charge at the beginning equals the charge at the end. Like the energy. The energy is conserved. Okay, continue. Kirchhoff's second law. Now I drew it already. Come on. Kirchhoff's second law, called the loop law. And Kirchhoff said the sum, and again, okay, the formula is enough for the exam. Okay, so you can say Kirchhoff's second law, the loop law is, the voltage in the loop is 0. So as a formula, you can write this, and I'll explain what that means now. Yep. So let me explain this. Kirchhoff said if you have a loop, this here has a voltage. Now, this provides, let's say V1. Whereas this here, if I measure this voltage, if I measure this voltage, and I measure this voltage, these consume, or they use it, because you know the resistor takes a volt per coulomb if it's a 1 ohm resistor. So what Kirchhoff said is that if you call voltages that are provided a plus, and if you call these ones minuses because they consume it, they use the voltage, then V1 minus V2 minus V3 minus V4 equals 0. But again, this is not so surprising because you could say V1 equals V2 plus V3 plus V4, that these voltages add to make a total voltage, and that total voltage should match this. So it's not a surprise. Now, what is the reason for this? Well, do you remember we said voltage is a joule per coulomb? 1 volt is 1 joule per coulomb. So the reason the voltage is 0 is because this voltage is like the input and this is like the output. This is like the 1 and this is like the 2. This is like the start and this is like the end. Conservation of energy says the energy at the start equals the energy at the end. So the reason for this loop law is because of conservation of energy, because a volt is a joule per coulomb. So that is the reason for this law. Okay, continue. Now, before we use these Kirchhoff laws, I'll just give you some tips, some advice. So don't forget, you can still use this law, V equals IR. And in fact, that is very useful with the loop law, because Kirchhoff's loop law is a total V. So you can calculate the V using IR. So that's still true. I'll remind you that. In fact, it's very useful and it's often used with the loop rule. Secondly, usually for these circuit problems, usually you only need the junction rule once. Now, of course, not always. I'm just saying. Usually the junction rule is used once per question. Usually. And often you need the loop rule more than once, maybe twice per question. And if the loop is the wrong way through a battery or a resistor, then the sign flips. What do I mean? So here, if I move this way around, then these are pluses and these are minuses. But if I turn around and head backwards, then I say this is a plus, this is a plus, this is a plus, and if I go backwards through this, it's a minus, okay? So if you go the wrong way in a loop, the signs get flipped, they're reversed. And you can choose any loop. However, as a tip, I recommend you choose the loop that has a cell in it. It's easier. And also, you should go with the flow. So, for example, in this one here, which way is the current going, left or right? Left. So when you make your loop, you should go left as well. It's easier this way. And definitely we need an example to explain what's going on. Okay, so I don't need you to write this down because when we do the example I'll repeat all of this. So let's have a look at an example. Come on. Right. This example should look familiar because we did this circuit where? When did we do this circuit? A simple circuit. So I'm deliberately doing this again except using Kirchhoff, and I will show you we'll get the same answers, and it's actually easier to do it using Kirchhoff's rules. So first, let's draw the circuit together. What have I got? I've got a 1, 2, 3, 4. Okay. This is a 1. This is a 2. This is a 3. And this is a 4. And in the middle here is a 5 volt. And I want to know what is the voltage and the current. Now, in fact, I think when we did this last time, we only found the current. Was it? So first I'll start by finding the current. Can I start? Yeah. So, we'll call this current that comes out I1. And as a little tip, because the current that comes out is I1, the current that goes in must be I1 as well. So the current moves along, and then what happens here? It splits. So the current that goes this way, we'll call it I2, and the current that goes up this way, I3. But then this current goes around, and in here it's still I3, and this one goes around, and in here it's still I2, and then they join back together and they make I1. Fine, okay. If we want to find I1, I2, I3, then we need to make 3 equations. Usually that means one junction and 2 loops. Okay? So how many junctions are there here? 2 junctions. We have a junction here and a junction here. But in fact, if we use Kirchhoff's junction rule, we'll get the same equation on both. So we'll just use one of them. So let's use this one here. What current is going in here? I1, 2 or 3? I1. And what is coming out of this? What is coming out of this junction? I2, I3. This is my first equation. Second equation, I make a loop. How many loops do I have?
2.
No,
3.
3 loops. I can go 1, I can go 2, and in fact I can go 3 on the outside. If you use my tips, which loops should we use? The top and the bottom. Why not the outer one?
There are no
cell, no battery. Okay, so let's start with the top one. Let's start here. Is this given me? Am I using or losing voltage here?
given.
Yeah, I'm not using or losing. Given or no, I need 2 catchy words here. Yeah, but I want something catchy. Catchy. I want like give or take. Yeah, we'll go with give or take. Is this given or taken? Given. So how much is it given?
5.
5 volts. Yeah. Walking along here. Walking along. Boom. Resistor. Given or taken?
Taken.
How many volts is it taken?
2 and 3.
Yeah. If we use the formula V equals I or, I can get the V. So what's the I here?
I3.
And what's the or? 2. So I'm losing 2 I3. Boom. Here I lose 1 I3. Equals, back to the start, 0. Okay, let's go bottom now. Start here. Give or take? Give. Boom. Take 3 I2 minus 4 I2. Let's write these equations out together. I1 minus I2 minus I3 equals 0. Is this I3 and I3? Yeah, nice. So I get I3, I get a 3I3 equals 5, and here I get 7I2 equals 5. Nice. Can I get I2? Yes. Can I get I3? Yes. So can I get I1? Yeah. So I say I2 is 5 over 7 amps. I3 is 5 over 3 amps. And I1 is something 15 and 35. So what's that? 50 over 21 amps is the I1, I think. Now if you check your answer from when we did this last time, I think we get the same numbers. Yeah, Kelvin, do you have them there? What's the I1, 2 and 3? It doesn't matter. I'm confident I'm right. And Calvin is not confident I'm right. Can somebody check their notes to see the answers we got when we did this? Ah, come on, you couldn't have lost it. We only did it like 2 days ago or something. Audrey, do you have it?
I total equals to 2.8. And
I total would be I1, so that does look like 2.38, so that looks right. You don't have any other currents?
0.71. And
0.71 looks like, and what's the other one?
1.7.
1.7 is this one then, yeah. Okay, so it looks okay now. Now, last thing to do here, I said I wanted the voltage. So how can I get the voltage here? This V1 will say. Yeah, IR. Do we know the I?
Yeah.
Yeah, and do we know the R?
Yeah.
Yeah. So I'll just write them here. V1 equals I3. So that's 5 over 3 volts. V2 would be 2 times I3. So that's 10 over 3 volts. V3 would be I2 times 3. So that's 15 over 7 volts. And V4 would be 4 times I2, 20 over 7 volts. So can you see how useful Kirchhoff is? We can quite easily get all of the currents and all of the voltages everywhere in the circuit. Huh? This question? What about it? You can also use Ohm's law. You think it's easier to use Ohm's law? Alright. Continue? Okay. We're just waiting for Audrey?
Yeah,
That's very unusual. Continue?
Yeah.
Right. Now, for this question, I want us to do this one together. Okay? I'm going to ask you each to do... Oh, flip. Yeah, something strange has happened to the TV now. Okay. Right, so, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'll give you the harder question next then, after this one. Yeah, this will be too easy for you. Yeah. So we'll start over with you, with part A. So, well, just before we start, let's just have a look. Can you see here? For this loop is I1. Okay, so this is I1, I1, I1. For this loop here, it's I2 and I2. And down the middle here is I3. Okay, so in a moment, I want you to draw this. No, actually, I'll draw this first, and then I'll ask you to do each part. So this is 12 volts, 4, 16, and this is I1. This is 6, 4, 16, of course, and I2. And in the middle, we call this one I3. And the letters are A, B, C, D, E, and F.
How many volts is in the middle?
In the middle? That's a 16 ohm. Is that what you mean?
No, how many volts is it?
Oh, in the middle here?
Yeah.
Oh, I don't know. We'll have to work it out. All we know is that this provides 12 and this provides 6. Okay, did you draw that? Right. Let's have a look. Good. Okay. Continue. Yes? Yeah. Right, so over to you. What I want you to do is use the junction rule at B. So if you can make the equation at B, so you have to ask yourself what currents are going in and what are coming out. So what's going in at B? Oh yeah, this current here is I1, so this one's an I1, and this side here is an I3, and down the middle here is an, I2, and down the middle is an I3 current. So what can you make about the currents at B here?
I1.
Yeah.
I2.
Yeah.
I2.
Ooh, close. I1 and I2 are going in, but actually I3 is coming out. So you would actually say I1 plus I2 minus I3. I could have sworn you said plus. She did. Amazing. I'm going deaf as well. Okay, apologies. So I1 plus I2 minus I3 equals 0. Can you write that down? Yes?
Is it wrong to write I3 minus I1 minus I2?
It is not. Okay. Next. You ready? Go for it. Do the same thing at junction E, please. Yeah. I3 minus I1 minus I2 equals 0. Did you write those down? Did you get that? Did you hear her? Yeah? Okay, go for it now, Audrey. What have you noticed about these two equations? Yeah. The only difference between them is an opposite sign. So, could you change one equation into the other? Would it be possible? Yeah, what would you have to do? That's it. If you multiply one of the equations by minus 1, you can change it into the other equation. So, in fact, the answer for A and B is the same. It's the same equation. Yeah. Okay. D, you have the loop rule. Congratulations. So, I want you to make the loop rule for the left loop. The A, B, E, F. Yeah, this loop. So, where will we start? No. Let's not start there. Let's make our life easier. Where should we start? Should we start here? Nah, let's start somewhere else. Where else could we start? Down here? Nah. Maybe somewhere in between A and F. What's between A and F? Yeah, let's start here. Yeah? Okay, so, the 12, given or taken? Given. Okay, so, can you write this down as she says it? We'll start with the 12. So we have 12. Okay. Then go this way. Yep. So what's next?
Taken.
Yep.
Minus.
Yep.
4.
Yep.
I1.
Good. Minus 4 I1.
I1. Minus 16 I3.
Minus 16 I3 equals 0. Good job. Okay. Next, you have to give me the loop on the right. Where will we start? Start at the 6 and go up or down. Okay, so 6. Yep, minus 4 I2. Minus 16 I3. Yeah, equals 0. Good job. Okay, Bruce, you have to give me the loop on the outside. Where will we start, Bruce? Good, and we go up or down?
Yeah.
Which, up or down? Oh, okay, so 12.
Minus 4 I
1.
Oh, I1.
Yeah, minus 4I1, good. Next.
And minus.
Yeah.
Minus.
Yeah.
Minus 4I2.
Gotcha, Bruce. Gotcha. It's plus 4I2. Why is it plus 4I2 for Bruce? Yeah, we are moving right, but which way is the current moving here? Left. So the sign gets flipped for the resistor. So this is plus 4I2. Yeah. Next.
Plus 6I2.
Oh, this is just a 6 volt.
Oh,
Yeah, so plus 6
that's it.
or minus 6. What do you think? What do you think? Minus 6.
What do you say before the fourth form?
Yeah, well, this one is a plus because it's backwards, and this one is a minus because it's backwards. You see, normally when you have a battery, you get voltage, right? But what's wrong with this battery? Yeah, no, give me simple English. What's wrong with this battery? It's upside down, isn't it? Because if the current, we should, remember I said for the battery, if you want to gain voltage, you have to have the positive with the negative. If the battery is backwards, we lose. Yeah, we're not supposed to go into the battery this side. We're supposed to go in from this side. So instead of plus 6, it's actually a minus 6 then. Yeah. I gave Bruce the hard one. And then back here, equals 0. Is that okay, Bruce? You don't look happy.
No, the second battery is
This one is a minus 6. Because we're going in the battery the wrong way. You know, if this is my battery, and this is plus, and this is minus, we should travel this way through it. But if we travel the other way through it, then it's the wrong sign. We've changed the sign. Yep.
It's like minus equals
It's like, it should be plus, this should be plus, but if you go the backwards, it's minus.
Okay, no.
Yeah, it's the wrong direction. Okay, next. Guys, ready? Guys! You, now. How many equations have we made? We've actually made 5 equations. 2 using the junction and 3 using the loop. The question now, for you, is we only need 3 equations. Which 3 should we pick? Which are the nicest 3 to pick? Well, let's start with the junction. Do we have a choice? No, because they're both the same equation. So we'll choose one of the junction. So the real question is, which loop equation do we choose? We have 3 and we need 2. So which one do we not use? No, there's a good one not to use. The A, B, E, F. No, we should use that. Yeah. A, C, D, F. The out loop. Use or not use? Yeah, correct. I think we should just use this one and this one. Because if you look at those equations, they both have I3 in it, yeah? They both have 16 I3. So you can cancel that. Yeah. Okay, continue. Right. So I don't want you two guys to feel left out, so you can help us with the next one. I want you two to make the equations. Okay. So, I'll let you draw it, then we'll make the equations. Got that?
That's for me.
I know, don't worry about the questions as yet, just the circuit. How many things are we looking for here?
One junction.
3 things. Yeah, I1, I2, I3.
The direction of the current is always given.
No, it's not. But interestingly, if you draw the direction the wrong way, it doesn't affect your calculations, except that your answer will be the different sign. But the number values will be the same. That's a good point, actually. Guys, just so you know, they don't always draw the current. You might have to draw the current. If you draw the current the wrong way, that's not actually a problem. It means your sign will be backwards in the answer, which is not held against you in the exam.
Is there a right way to do
There's only tips. So, for example, here, I would draw the current going up because it probably is coming out of the back of the cell here, you know. And likewise going up here. But the real question is, in the middle, yeah, it's probably going down because these two come in and combine. So, right. Over to you. So what I want you to do for me is your choice. Do you want to make a junction or a loop equation? Which loop do you want to make? You have 3 loops. Lefty, righty, or outside? You go for left. Okay, where will we start? Good, okay. So, 50. Write this down. 50. Next. Very good. Minus 10 I1. Minus 5 I1. Minus 4 I3. Equals 0. Very good. Okay. Now, Wookie, what do you want to make? A loop or a junction?
Loop.
Okay. Righty or outer?
What do you want?
No, what do you want? Your choice.
Outside?
Okay. Where will we start?
50.
50. Okay, go for it. 50.
54 minus 10 I2.
Oh,
I1.
10 I1.
5 I1.
Minus.
Minus 5 I1.
Yeah.
Plus 2 I2.
Plus 2 I2.
Plus 3 I2.
Plus 3 I2.
Minus 4.
Minus 4 equals 0. Very good. And back to you now. I needed one more rule from you. So you need to use the junction rule now. So let's take this junction. What equation can I make here?
I2.
Yep. Oh, this one's kind of, yeah, this here is an I1 and this here is a I2. Yeah, so what have we got? I3.
Minus I1.
Yeah.
I2. Equals 0.
Good. Okay. Very good. Let's write these equations down together. So can you just read them back to me? What was the first equation?
15.
Yep.
Then I1.
Yep.
Minus 5 I1.
Yep.
Minus 4 I3 equals 0.
So like this. You can combine the I1s. Yeah. What was the second equation? 50 minus 15 I1 minus, plus 5 I2 minus 4 equals 0. And the last one? Yeah.
I1 plus I2 minus I3.
No, I don't think it was that.
I3 minus I1 minus I2.
Equals 0. Okay, let me just write these a little bit neater. So the first equation is 15I1 plus 4I3 equals 50. The second one is 15I1 plus 5I2 is, let me see, that's minus 50 plus 4, minus 46. Now that makes me sad for some reason. It feels wrong. I guess we'll find out now. And the last one is, I'll just write it as I1 plus I2 minus I3 equals 0. Thank you, thank you. How is it wrong? Oh, because that's a minus, isn't it?
The minus
So I'll make this a minus
one.
and then make that a plus. Now that makes me happy. Yeah, okay. Continue. Now, the real question is, what's the best way to solve these? So I'll give you a little tip. The tip is, you choose one current to delete from all of them. So you must pick a current that's in all the equations. Well, you don't really have a choice. There is only one current, I think, that is in all of them. What is that? I1. So can we delete I1 here and here? Yeah. What about here and here? Well, nearly. Yeah, we'll have to multiply. What should we multiply here by? 15. Now can we delete? Yeah. So, we minus the top two. 15 minus 15, gone. No I2s, minus 5 I2s, 5 I2s. 4 I3s minus no I3s leaves me with 4 I3s. And then lastly, 50 minus 46, 4. Okay, 15 minus 15, gone. Minus 5 I2, minus 15 I2, minus 20 I2. No I3s, minus 15 I3, 15 I3, equals 46. Yeah? Okay, I should divide this equation by 4. Or, yeah, because I want to make this a 5. So I can divide this by 4. Or, if I want, I can multiply this by 4. Yeah. So now I get 20 I2 plus 16 I3 equals 16. Minus 20 I2 plus 15 I3 equals 46. I should add these together. What happens to my I2s? Cancel. 31 I3, 62. So, nice. That is 2 amps for I3. Now, what should I get next? I can put this back in, say, here. Yeah, so I can get 5I2 plus 8 equals 4. So I2 is minus 4 over 5. Now what is the meaning of the minus answer here? Well, it means on the picture the I2 is the wrong direction. So on the picture here the I2 is actually moving to the right instead of to the left. Now I could have guessed that from the start, because notice the huge difference between these two cells. This is much bigger than this. So when they meet here, it's almost like this guy is able to push through the smaller current and force it backwards. If you picture it like a group of people, 50 people here, 4 people here, when they meet, it's going to push this one backwards, kind of like this. So the minus is fine. And lastly, how can I get the I1? The I1 is I3 minus I2. So is that 2.8, I think. Do I know I1? Yes. Do I know I2? Yes. Do I know I3? Yes. Finally, what direction are the electrons moving here on this side? Are the electrons moving up or down?
Electron.
Well, which way is the current moving?
Down.
Down, because the I2 is negative, the picture is wrong. So the current is moving down. And so which way are the electrons moving? Up. Now, I like this in the exam, because this was taken from a past section B question. It was like half a section B question. So this question here, in total, I think was something like maybe 10 marks.
10 marks?
Yeah, about 10 marks, which is 10% of the exam. So you get a nice boost to your marks by doing this question carefully. And what's also nice is if you have your trusty Casio calculator, you can check your answer. If I go into mode 52, I can type in these equations. 15 I1, no I2s, 4 I3s, and 50 volts. 15 I1 minus 5 I2s, no I3s, and 46 volts. 1 I1, 1 I2, minus an I3, and no volts. So, I1 is 2.8. That's what I got. I2 minus 0.8. That's what I got. And I3 is 2, which is what I got. So I would know in the exam I've just gotten full marks on this question because I solved the equation correctly. So I really like this Kirchhoff question in the exam. I think it's a great question in the exam. It provides a nice couple of marks. Helps you out a lot. Okay. Do you need to write anything else down? It's not too difficult. It doesn't come up in every exam, maybe 60% of exams. Yeah. It's great when it's in a section B question. So who has studied this Kirchhoff before? You knew his name, so you've seen like this before? Yeah. And you've seen this before? Yeah. The same difficulty? Or the same type? Yeah. Have you seen this before? No. No. Guys on my right? Have any of you studied this before? This is a new topic? Yeah. Okay. Continue? Yep. So I think that, I don't know if I have another example. Yeah, I have another example, but it's, the reason I have this as a double lesson was because I was going to do a few examples, but yeah, I have two more examples, but I think you all get the idea. You all gave me the correct equations, and I don't think there's a problem. So if you want, if you finish the ones in the workbook and you want to practice more, I have two more. So you can watch this video and just pause it. So I have this example, which I won't do because I think I've done enough of these. And I have this example as well. By the way, I've taken all of these four examples from, not this one, but this one, and this one. They're all past exam questions. But you can see, it's all the same thing. Oh, they just want you to find the voltage here. That's all. Do any of you want to take a picture? Well, you can get it from YouTube if you want. How many circuits did I give you in the workbook? Three circuits? No, I think I would like you to do these ones. This one I think is a good one. Can you just take a picture of this? I want you to do this one as well as the ones in your book as homework. What? Just make sure you turn your Instagram filters off, okay? No, don't add any dog ears to the TV. Uh-oh. What are you talking about? Are you too lazy to take a picture?
Yeah.
Disgraceful. Disgraceful. Oh, come on!
Wow. Amazing TV.
I don't know. Now, let's be fair to the TV. It could be a problem with my laptop, although then it shouldn't work when I press this.
Check this.
Alright, how do I... Menu... System? No, settings? Sleep timer is off. I don't know. What else could it be? Sources maybe?
More.
It's all enabled.
Yeah,
More.
Okay.
Menu timeout.
Yeah.
Ah. Well, oh, dude. Come on. Right, let's try this again. Menu, system. Oh, come on. Is somebody messing with this on their phone? Settings. What was I at? More. Off.
TV off. Oh no.
Off. Disabled. No, don't share videos. Standby. Like last state? What the heck? Yeah, why not? Enabled a virtual remote. Nah. Okay. Did you get the picture? Got that? We'll finish there. Do you have class here next, or are you off?
No.
Lunch. Good.